This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. And that is Big Data Masters program. And currently, we are going through with AWS Cloud. And in the previous session, what we have discussed about EMR, uh, how to create EMR with EC2, and then how to create an EC2 instance. EC2 instance we have seen. Then we have started a new topic, that is Athena, that is another service or serverless service from the AWS side. And it is utilized in order to query the data which is placed inside the S3. And how we are doing, how we will be able to access that particular data which is placed inside S3. So what we are doing over here, we are creating certain tables with the help of Athena. And those particular tables are going to take the data as an input from the S3, and then we will be able to query that particular data. That is perfectly fine, but there are certain aspects like how the AWS is going to charge you, because this is the serverless service. And the serverless service is not given free of cost. Over here there is no need to create a cluster. We just need to have Athena, and then we will be able to query onto the data which is placed inside the S3. Okay, so how the AWS is charging based upon that we have seen, like based upon the scan data. Whatever the data we are going to scan, the AWS is charging on that particular data. Then there are certain things like how to create the table, and certain methods how to create the table. And we have gone through with the very basic method, and we have created the table and scanned the data from that particular table. So we have done that particular stuff. Now, once we have curated the data, once we have curated the data which is placed inside S3, then we have seen that particular data was scanned completely. That particular table was the file was scanned completely, because that was the CSV file. And if I'm going to take a single column, it is going to scan the entire file in order to provide me that particular data. Okay, so how to do the optimization on to top of that particular stuff, that we are going to learn. Second thing, uh, over there we were defining the schema, each and every column we were defining, but is there any way to infer the schema? So we will be looking for inferring the schema as well. So the topics for the day, what we will be going to discuss, that will be how to optimize the query, or how to optimize the performance in Athena. So that is the first topic. Second, how to infer schema in Athena. So these are the two topics which we will cover in this particular session. So let's proceed with how to optimize the performance. And for this, what we will do, we will just try to log into the AWS account. So we have logged in into the AWS console, and we are having Athena as a service. So we will try to get this particular service. And over here, show tables, say show, uh, show database. So database, so it is going to sorry, a minute. Okay, so this is the database booster analytics what we have created in our previous session, and select star from booster analytics dot small flight data limit 10. This is the query we in order to select uh, in order to list top 20 list 10 records from that particular data. And this is the table, a small flight data, that is a table. And once we are scanning, so we are listing, we are trying to get the 10 record, then also it is scanning 531.04 KB of the data. So over here, like whatever the query, what we are writing on to top of the table, those particular queries are not optimized. So how we will be able to do the optimization onto these particular uh, Athena tables? So there are certain ways. First way is to optimize it with the help of partitioning. Partitioning and bucketization, these particular things we can apply in order to boost the performance. Partitioning, let us see how to apply the partitioning. So we are having a particular data, say I'm going to create a Python file, and I'm mention week 17 day 27, and I can mention say AWS. Okay, so what we are going to do over here, we are just going to create a Spark session. Okay, that is perfectly fine. We have created a particular Spark session, and let me try to list top 20 records. So small flight dot show, that is going to list top 20 record. So this is uh, with respect to a small flight data which we that is in a CSV format, and we are trying to read this particular data. Now what we can do, we can perform the joining onto top of this particular data, and we can do the joining with with we are reading the another data frame, that is planes data, another data set we are reading, and we are going to do the joining up. So this is the way. Let me try to copy this particular code. So over here what we are doing, we are just trying to join these particular data frame, that is perfectly fine. We are having two data frame, a small flight data and planes data, and we are trying to join. So we have applied the join condition, that is join df small df a small flight data, the data frame dot join with planes data, planes df, and based upon this particular condition the join type will be inner one. And over here we are selecting the unique column, and then we are creating a data frame based upon the unique column, and finally we are writing that particular data frame, okay, onto this particular path. Onto this particular path we are going to write this particular data. Now what I can do, I can do the partition by, and inside the partition by, let me try to think based upon what I can do the partitioning. Flights data, and say small flight. This is the small flight data, origin, destination, airtime, tail. Okay, let me do the partitioning based upon the destination now. So I'm going to do the partitioning based upon destination now. So over here, what I'm going to do, I'm going to add a partition by clause over here and partition by. Perfectly fine now. Now what will happen? The output based up what I'm going to write onto this particular path, that will be, that particular data will be partitioned by destination, and we will be having different uh, folders in the output path. Just have a look. We will be having different folders onto the output path. So the output path is this one, output. And why we have done the partitioning? Because if we were scanning the data with CSV file, and if we are scanning the single column only, at that moment it was scanning the entire data. Okay, it was scanning the entire data frame. So now what we will try to do, we will try to minimize the amount of scanning. And for that particular perspective, what I have done, I have done the partitioning. Just have a look. So this is, I think, output. Okay, so what we are having, so if destination equal to ABQ, so with respect to destination ABQ, we are having this particular data. So only this much of data is scanned. Previously, if I was selecting, say, select a star from the small flight table where destination equal to ABQ, so it was scanning the entire records, all of the records were scanned. But at this moment what will happen, only this much of record will be scanned now. So let me try to show you. Okay, so select star from booster analytics dot table where where destination equal to ABQ. ABQ. Okay, column not found. So DST, that is there. Just a minute. Okay, that is of also string type. Mm, just a minute. Airtime. Why airtime is coming now? Hmm. ABQ cannot resolve or requested not authorized to access the resource. The query boost analytics unless qualified. The query please post an error. So where destination equal to column not found.
Reason where we define the column name.
So it is taking single inverted comma. So double inverted comma was not taken. Okay, so that is with respect to Athena. So just have a look. We are selecting just one column. We are just selecting one flight, one destination, that is ABQ, and with respect to this, like we are having this much of record. So ABQ is a destination, and we are selecting just ABQ, and still it is scanning the entire data. Okay, it is scanning the entire data. Now we just want to do the optimization on to top of this. So how we will be able to minimize this amount of scanning. So for this, what we are going to do, we are having this particular data. So I'm going to load certain data. I'm creating the S3 bucket over here. I'm having, say, console S3. So inside the S3, I'm going to create a folder. So this is Big Data Analytics, Big Data Booster Analytics 2. And over here, I'm going to create a folder and say flight data, new. Okay. So this is a folder. And in this particular folder, what I'm going to do, I'm going to upload, upload add folder. So upload from here flight data output one. So uh, hmm, what I can do, I can perform drag and drop over here. Say I just want to have San Francisco. Up to this particular destination, I just want to move these particular folder over here. Okay, so those particular folders will be added over here. Okay, so just have a look over here. I'm having this particular cancel. So upload. So I have created a new folder, flight data new, and over here I have moved certain partitions. Today we are going to learn certain new things. Okay, like how to do the optimization. Probably in your organization, in your future organization, you will be getting these particular issues, and you will be able to tackle. And you just recall this particular stuff what we are going to do today, and then you will be able to handle the issue. Okay. So uploading is going on, and it is going to upload the data which is available in this particular folder. San Francisco. Okay. So upload is happening. It is going to upload this particular. It is going to upload all of the folders, partition folders, onto the path that we have given. Now, meanwhile, what we can do, we can create another table. So what we can do, we can create a table. So create a table from source. So S3 bucket, and we are having data onto the S3 bucket. That is perfectly fine. And what we can do at this moment, we can give a table name, say small flight optimized table. Description, no description, choose database. So Booster Analytics is the database. That is perfectly fine. Browse the data. So from where I'm going to browse the data? On Booster Analytics 2. Okay, inside Booster Analytics 2, I'm going to take the data from flight data new. I'm going to choose this particular folder, and data type Apache High file format. I'm going to uh, keep this particular uh, keep this particular stuff default file format, that is CSV. So let me check, is this CSV file or not. Okay, so that is the CSV file. Now over here, if you are able to see CSV file, so we have selected the CSV, and then what we are going to add, so properties, each and everything is fine. Field delimiter, that is comma. Now we are going to add the column names. So column names we need to add, and we will move with respect to the stuff what we have covered in our previous session. So so we are having these particular columns. Let me try to copy and paste it over here as well. So year, that is of string type. Create table. So column name year, that is of say string type. Okay, then add column. This is the stuff what we have done in our previous session as well. Year, then we are having month. Okay, so column name month. Okay, and that is of say string type. So data type you just need to provide day, that is of string type. Add column day, then that is of string type. Then but we are having depth time. So with respect to the depth time, what we are having fixed string. Okay, we can add the column and provide the data type with respect to the data which is available. So say string, then depth delay, then we are having say arrival time. arrival time, and that is of the string type. We just keep on adding these particular arrival time, arrival delay, and what we are having carrier, and what we are having tail num. Okay. Oh, okay. What we need to do, friends, and just like whatever the data we are loading onto onto that particular location, we just need to provide the schema with respect to that. So in this, what we are having output, and let me try to open this one. So with respect to this, we need to define the schema. So that is, we are having how many columns? We are having 20 columns. And what we can do, we can mention, say, over here, header to option and header, and we can have header to perfectly fine. So let me run this, and we will be having the header information at this moment. I just want to have the header information, so it will be deleted. Just a minute. So let me wait for the execution of this particular code, and once this will be executed, we will be able to get the information about the header as well. With respect to that particular header, I'm going to create the table. So the query is being executed, so we are having the data, and now just have a look over here. We will be having the header information. That is perfectly fine now. So this is the schema. Based upon what, I just need to define the columns, create the columns. Now this is the schema. So uh, hmm, month, day, depth time, depth delay, arrival time, arrival delay. So that is, I think, fine. So up to so far, month, year is not available. So year is not available. We can delete this year column. Month, day, depth time, depth delay, arrival time. Month, day, depth time, depth delay, arrival delay, carrier flight number, carrier. Then tail num is not there. So instead of tail, we are having flight. Flight, and we can refer this one. Flight, then origin, air time, distance, hour, minute, and type. So we are going to create a particular table based upon the data, but we are having model, engines, seats, and speed, and then engine. So we have destination column over here. Origin destination. Origin is there. DEST. Okay. So partition by destination. Okay. 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 Partition by destination. That is perfectly fine. So what we are having, we are able to create the table. Let me provide the data type. Engine, say we are having integer value or say string. Let me give string. So string will not create any issue. String. Okay, you can change the data type. There will not be any issue. String. String. Then what we are having? String data type. String. Then string. String. You just need to pay attention over here. The next thing that we are going to do on to top of this particular table, year time, say string, flight, string, string. Okay, so the data type with respect to each and every column has been given. Now, what we just need to do, partition detail. So this particular column is partition based upon destination. And column type says string, that is of string. Now just have a look with respect to the columns that you have added. So this is the query. Say create table if not exist boosters analytics small flight opti. This is the table name, and these are the columns. Month is of string type, day string type. You can change the data type. There will not be an issue. Type type. Do we have type over here? Type is there. So when manufacturer string is each and every column we have added over here. Then what we need to do, we just need to have this particular data in partition format. So this particular table will be partition based upon string, and then row format, serialization, deserialization with properties. So delimiter, this is the, you can say, comma separated file stored in this particular format, and location is this one, and this is of CSV type. So this is the command in order to create the table. Now let me create the table. Okay, so the table is created. So the table is, say, run again. So the table has been created. Query is successful. And let me try to copy this particular command. Copy and paste it over here. So what we have done, we are able to create the table based upon the data what we are having onto that particular path. So we are able to create the table. We are able to create the table. Now, what we want, we just want to run certain query onto this particular table. So this is a small flight opti. This is partition table. Let me try to run a particular query. I just want to have 10 records from this particular table. It will not display any record. We are able to get the record. Okay, so we are not able to get the record. Yes, that's what I want to show. We have executed the query boost analytics small flight opti. This is the table and limit 10. So at this moment, it is not going to list any record. Okay, we are we have created the table, and the table creation was successful. And same thing we have done with the previous query. Like once we have created small flight data table, that was non-partition table, so that table was able to give us the record. But over here, once we have created the partition table, it is not able to, it is not providing us the records. So what is happening over here? uh, Over here we have created a partition table, we have created a partition table and we have provided the path, but those particular partitions are not loaded in this particular table, so what you need to do, you need to run a particular special command over here in order to load that particular partition data inside this particular table, and what is that particular command? That is msck repair key, and msck repair. So you just need to run the msck repair command in order to load that particular data. So how you will be able to run? So this is the table name that you are having, and before this, what you just need to do, msck repair, you are just going to repair this particular boost analytics dot small flight opti. This is the table and you are going to repair, and with the help of this particular command, what will happen? Let me write it over here. After creation of partition table, the data is not loaded in in the partition table. The partitions are not loaded in created table. Now, now you need to run a special command to load those partitions in that table. In that table. So this is the command, and msck repair. This is the syntax. db db dot table name, and you can mention this in this particular way. So syntax, and this is the example. So you just need to run this particular command msck repair, and once you are going to run this particular command, all the partition delocate, delete, deny, mismatch input, msck accepting, alter, analyze, call, comment, repair table. MSCK repair table. That is not working. MSCK expecting, alter, analyze, comment, create, Prepare, refresh, rest, revoke. Prepare, is it changed to prepare? Let me try to proceed in this particular way. MSCK prepare table in Athena. So we are just looking for the command. I think the command is correct. MSCK repair table name. This is fine. MSCK repair table orders. Hmm. So we just need to remove this. Let me try to do MSCK repair. Hmm. Okay. So just have a look. So that particular stuff is not required. DB dot table name is not required. So we were writing in this particular, but I have done the execution in that way as well. Things has been changed now. So MSCK repair, and then we just need to mention the table name. DB dot table, that is not required. Table MSCK repair and the table name dot table. So MSCK repair and table name, and just have a look what has happened. So whatever the partition which we have created, small flight destination altered, these particular partitions are loaded. Okay, added partition this, added partition this. So these particular partitions have been loaded over here into the data, into the table that we have created. Now try to run this particular query, previous query that we have executed. So previously we were trying to execute this particular query. Let me try to mention a preview of this particular table and small flight data, and let me try to scan 10 record. Okay, now what we are able to get, we are able to get the 10 records, and just have a look, we are able to scan 26 KB data only. Guys, are you able to get? Previously, once we were scanning the data, like we were scanning the data from the small flights and say limit 10. This is the same query what we are executing at this moment. Say run. So it is taking, it is going to scan this much of data. But now what we have done, we have done optimization onto top of this particular data or table, and we are having partition data, and now we are doing the execution, then it is scanning this much data only, that is 26 or 73 KB. Okay, it might be keep on changing, like it might be possible, like say in this particular execution we are getting different record, so it might be keep on changing. So then say what I can do, where, let me try to move with where clause, and this was the query where destination where destination equal to abq. Okay, single inverted comma, where destination equal to abq. We just need to get the records with respect to the destination abq. Previously it was scanning I think almost 531 KB of data But now what will happen? Just have a look. At this moment, it is scanning 5 KB only. Friends, just see what we have done on to top of this particular table. Now the record scan have been reduced drastically. Previously, we were scanning almost the entire table, and because of that particular scanning, we were paying heavy amount to the AWS. But what we have done, we have done the optimization onto top of the table, and we are able to minimize the scanned data. Just have a look. Swati, Naresh, Rahul, Raj Babu, Shivama. Are you able to get
Yes, sir. Yes, sir.
any
It's a
confusion?
yeah. It's a very less amount.
Yes, yes, yes. That's the betterment what we have done. So let me explain it once again. So we are going through with Athena, and in the previous session we have created a table, and once we were scanning the data from that particular table, so it was scanning the entire data. Almost the entire data was scanned. Small flight data that was non-optimized table, and that is not performant. In order to boost the performance, what we have done, we have created a partition table. So at this moment, we have created the partition table. Now let me show you the difference. Previously, we were in the previous session, we have created the table with this particular command. Uh, huh. So this was the command which was there in previous session. So create table, then the column names have been mentioned, row format, serialization, deserialization. Okay, forgot about this. And the field delimiter is comma, because this is the CSV file, and store as a format. So input and output format has been given because Hive format has been considered, and this is the location and table properties classification CSV. So over, like if you are running this particular command with say create table and location is this one, you are not providing these particular properties and serialization as well. That will work as that will work. There will not be an issue. You just copy this particular command and run over there, you will be able to get the table. What I want to show, what I want to show you that the difference, once you are going to create the partition table over here, you are having destination, but once you are creating the partition table, so the column based upon what we have performed the partitioning, that will not be the part of initial schema definition. So over here we are defining the columns, but the the column based upon which we are doing the partitioning, that will be out of from here. So if you are writing the query manually, although like if you are going through with GUI, then uh, the Athena will take care about these particular stuff. But if you are writing the query by yourself, then you need to move in this particular way. So the partition column must be outside from this particular column definition body, or column definition stuff. So you, what you are having, you are able to create a partition table. Rest each and everything is fine. Now what is happening, say we are having this particular S3 path. Just try to focus over here. We are having the S3 path, that is the S3 path over here. And over here, onto this particular path, this is a path where certain third party applications are dumping the data. Okay, say like max of the persons are from telecom background, you can take it in this particular way. Like this is the path where the hourly KPI or daily KPIs have been added in a particular folder. Say uh, 7th October file, 8th October file, 9th October file. So these particular partition, you can think that like we are having different dates KPI data. Now these particular folders are carrying the data of a particular of a particular day, or like these particular folders are having the data with respect to certain partition. So certain third party applications are dumping the data over here, or customer is writing onto this particular stuff. But it is not like, say, if the data is dumped over here and we need to again and again uh, like create the table based upon that particular data. So just have a look. So previously we have loaded the partitions, up to this particular San Francisco SAN. Okay, so we have loaded the partition up to RNO. Let me show you. Over here we are having the folders up to RNO. So this is the last folder that I have added. Now say I'm having a 4-day KPIs as well, and it has been dumped onto that particular path. So let me try to copy it and move it onto this particular path. That is perfectly fine. I have added certain more, you can say, folders. I have added certain more folders, or certain more data has been dumped down. And now just have a look. So once the execution is done, then we will be trying to run the query onto top of that particular table that we have created. Now the data is being uploaded onto that particular path. Okay, so data has been uploaded, and this is the query editor. And we have uploaded the data with respect to, say, San Francisco, SAN. SAN, it might be any, you can say, airport name, but I'm taking it, say, San Francisco. And let me try to, I have loaded the data onto that particular path, but it will not list any record. So it is not listing any record because the partition that you have uploaded over there, okay, the data that you have uploaded over there with respect to this particular data, these particular partitions are not added. So it might happen certain third party applications are being dumping data onto a particular path, and onto top of that particular path you have created certain tables, but until and unless you are not adding those particular partitions, you will not be able to get the data. So how to add those particular data? You just need to run the MSCK repair key once again, and let me run it. So what has happened? MSCK repair table, that is perfectly fine. MSCK repair table key. So mismatch SCK expecting, run again. I don't know what is happening. Okay, so now the query has been taken. So we have added how many partition? We have added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Uh, okay, we have added these particular partitions, say up to TUS. So with respect to each and every partition, so we are having those particular partitions have been added. You can think the dates with respect to new KPI data has been added over here. Those particular partitions have been added, and now you will be able to run this particular query, like select star from the booster analytics dot small flight opti where destination equal to San Francisco. Just have a look. Now you will be able to get the data with respect to San Francisco. And here it is. You are able to get. Now just have a look over here. Once we were getting the data with respect to ABQ. Okay. And at this moment, what we are getting, we are getting the schema, like we are having the single column only. Yeah. Like month, day, dep time, dep delay, arrival delay. Yeah. But once we are querying onto San Francisco, SAN, so it is showing me the data in this particular way. Okay, say month is given over here as well. Why it is happening? It's very simple. Why it is happening? Why I am getting the data in this particular format? Why, like month is there, day and day is there, dep time and dep time is there. Why it is happening? Swati, why it is happening?
Sorry, sir, I was not on screen. What you have asked? Hello.
So I am querying onto the data, small flight where destination equal to San Francisco, and I'm getting say this particular outcome month. But over here, I'm having this schema, and I'm having one record with respect to the schema only. Yeah. And but once I'm executing say ABQ, so I'm getting the outcome with respect to this only. Like I'm not having the repeated month and day. Why it is happening?
So I too don't have idea.
Okay, so what has happened, friends? So previously, once we have done the execution of this particular code, once we were trying to get the outcome, or once we were trying to write the outcome, uh, post joining those particular data frame, we have not used option header equal to true. And at that moment, like header information was not available. And then we have loaded certain records or certain uh, folders with respect to that only. So at that moment, or certain partitions with respect to that only, like data without header, then we have added this particular clause and we have again executed it. And the remaining, you can say, these particular partitions, San Francisco to say TUS, so these particular partitions are having data or having outcome with header as well. So header information is available over here. So we have loaded these particular partitions the after the execution of this particular query, and because of that only these particular partitions are carrying header information, and because of that particular reason we are able to see header information and the schema that we have created inside this particular table. So that is because of that. We are having header and we are creating the schema as well, so things will be visible twice, right?
Right, sir. Right, right.
Okay, so this is what, like with respect to uh, Athena. And what we are able to see, we are able to done certain optimization. Now scan record are very less. Previously if we were executing say this particular, just try to focus on to this, where I'm just writing this particular clause, where destination equal to ABQ, and let me go paste it over here, where destination equal to ABQ. So let me do the execution and say, see over here, the scan data, it is going to scan the entire record. This is like based upon the table which is not optimized. The table is not optimized, and we are scanning the entire data. Okay, we are scanning the entire data. This is the complete data what we are having. But over here we have done the optimization. We have partitioned the data. We have partitioned the table based upon destination. And once we are running the data query onto top of this, it is scanning just 5 KB. Okay, this is scanning 5 KB. You can think like how much optimization you have done over here. Previously it was scanning almost 600 KB, and now it is scanning only 5.78 KB. And see like what is the optimization that what is the amount of optimization that you have done over here, because you are paying based upon the scanned data. So you just need to focus onto the optimization related stuff, and MSCK repair key, that is important from the interview perspective as well. And the interviewer can ask in different ways, like if you are having certain application which is being dumping certain data onto a particular path, and you are not aware about that particular data, so how you will be able to get the information that certain data has been dumped? Okay, certain new data is there, so how you will be able to get? He can ask in the different way. Say I am having certain partitions inside my in my location, in my data lake. I'm able to see the partition, but once I'm running the query onto top of those particular partitions, I'm not able to get the data. Why it is happening? So because those particular partition which are being dumped or which are available onto the data lake, those are not loaded inside the table. So once you are able to, once after like adding those particular partition in table, then only you will be able to query onto that particular partition. Until until and unless you are not loading or adding those particular partition, you will not be able to get anything. So that is with respect to optimization onto top of Athena tables. We can like do a lot of type optimization. Say we can while queuing onto the table, we just need to select the required number of columns. Don't move with select star. Select star is going to scan the entire table, all the columns. It is going to take all the columns. Instead of a star, you just uh, mention the required columns only, then also you will be able to optimize your query. The scanning data will be reduced. So a lot of optimization you can do, but this is the best one. And that is like good from the, that is important from the interview perspective as well. That is the first stuff that we want to learn in our today's session. Just have a look and ask if you are having any doubt. All of you, if you are having any doubt, you can ask. Any confusion, anything?
No, sir. No, no.
Raj Babu, Rahul, Swati, Naresh, Shivam. Naresh is speaking once
No, sir. No,
again.
sir.
Okay, okay,
All clear, sir.
okay. So this is with respect to the optimization that we can do onto top of Athena table. Now what we can do, how to infer the schema. So second option is how to infer the schema. This is important from the interview perspective. Let me mention important. Okay, how to infer the schema. Athena. So how to infer the schema? Now over here, we have created the table based upon the first option, that is loading the data with from the S3. Now, what we are going to do, we are going to create the tables with AWS Glue Crawler. Just click on to this AWS Glue Crawler. Okay, and you just need to give the crawler name, say Booster Analytics, and say flight data boost analytics, flight data boost analytics. So tag, I just don't want to give any tag. Then you just need to click on to next. Then data source configuration. Select one or more data sources to be crawled, or select existing tables of your glue data catalog. So what you are going to do, you are going to select data source, and based upon the data source you are going to crawl. So data source, add data source. So with respect to the data source S3, and then browse the bucket. So boost analytics 2, and inside the boost analytics, the flight data, and inside flight data we are having multiple tables. Unsaved, uh, so over here we just need to give the folder name, Athena test. So that is perfectly fine. Okay, choose what is mhm. S3 in different account, scroll subfolder. Crawl new subfolder only, crawl based upon event. Crawl also folder only, crawl new. Okay, crawl all subfolders. Whatever the data which is available onto this particular path, that will be crawled. Add S3 data source. So then create, you just need to click onto the next, and IAM role. So you just need to create an IAM role, and BDA filter. Okay, just create a new role over here, and create the role and say glue role. Okay, create glue role, and choose an update. So I just want to update this particular role. IAM management. So over here, this is the glue role, and what I'm going to do with respect to this particular role, I just want to add policy. So I just want to have S3 access, S3 full access, that is perfectly fine, and add permission. Okay, S3 permission, that is read and write, and say Athena. I just want to Athena, add permission, sorry, as policy Athena, Athena full access. Just try to think in this particular way. Okay, that is perfectly fine. Now AWS role is required. For AWS role, what AWS role is doing over here? Say you are having one service Glue, okay, another service S3, and then another service Athena. So these three services are there, and what you need to do, you need to communicate among these particular service. So you are providing Glue the full access to S3 and Athena. So then you will be able to access the data from this particular location S3 or from this particular service, and you will be able to query the data from Athena console. So because of that particular reason, we just need to have the glue role. So uh, hmm, glue role, my role. So glue role has been selected, and lake formation configuration optional, security optional. Let me move, choose the database. So we are going to choose this boost analytics database only. If you are not having a particular database, then you can create a new database or add it over here. Table name, then what I can do, small flight and glue. This is the table name, and minimum table threshold option, optional, advanced options. I'm not moving that with the advanced option. Group crawler schedule. So over here, like once when you want to run this particular crawler, say if you are getting the table data onto a particular path at hourly, then you can run the crawler hourly basis, daily basis, weekly basis. Based upon the data generation, you can schedule this particular crawler. I just want to run it on demand, so run it on demand, and then review and create crawler. Okay, so review and create crawler. So the crawler has been created. Now what you just need to do, you just need to run this particular crawler. Now over here on side the Athena console. Athena console, what we are having, we are having two tables only. Now what I'm going to do, I'm going to run this particular crawler. So glue crawler, this is the crawler, and let me try to run this. I have clicked onto the run crawler. So crawler is starting. Just have a look onto this particular time. The status is running, and it is running. And once it is successfully executed, completed, then we will be able to see the table. Okay, we will be able to see the table inside the Athena console. So it is keep on running, and it is in running state. Data sources, classifier tags, crawler run. The crawler is in running state. It is okay. So it has been completed. So it has been completed, and just have a look over here. Just have a look over here. Let me refresh it, and what we are able to see, we are able to see small flight glue Athena test. So this is the table that is created based upon that particular crawler. And we have not given we have not defined the schema. It has been taken automatically based upon the data that is available. So preview table, and it is going to list top 10 records from that particular data, right? Simple, na? It's very simple. There's no need to create columns and all. You just need to run the crawler, and then tables will be created automatically. Yeah. Right?
Right, sir.
Interesting, huh? Swati,
Yes.
Shivam, Rajbabu,
Yes, sir.
Rahul.
Yes.
Okay. So let me repeat it once again. Huh? So what we have done, we are trying to infer the schema in Athena. Okay, so inside the Spark, what we have seen infer schema, we just need to add the property infer schema true, and Spark is taking care with respect to the columns and the column names and data type. These particular things, column names that is based upon the data that you are having. So so Spark is taking care about the inferring schema with respect to the infer schema clause, but inside the Athena, we will be able to have this particular option by glue crawler. So how we are moving with respect to creation the tables with glue crawler, what you just need to do, you just need to click onto the table and views, and over here we are having options like create from the S3 bucket. So previously we have created the tables based upon S3 bucket. Now you just need to proceed with glue crawler. So once you are you can say once you click onto the glue crawler, then it is going to ask what is the crawler name. So after providing the name, then it is going to ask what is which one is data source. So data source, you just need to define the data source. Then like after defining the data source, it is going to ask certain security and all. Then then the fourth step, what it will be, scheduling. Just let me try to mention. So these are the steps in order to create the blue crawler. Steps: open Athena and click on create table and move with create table with glue crawler. Glue crawler. Then once you open the glue crawler, then there are certain steps, like set the properties. You just need to give a crawler name. Dollar name. Then second step, you just need to choose the data source. This is like need mention it clearly over here. You just need to mention the data source and classifier. Then fourth step, the security settings. We are just moving with the default settings. No security settings, or we just need to provide, create, or provide IAM role. IAM role over here. And IAM role, that is access for S3 and Athena So this we have done over here inside the security phase. Then third, like output and scheduling. So over here we are mentioning, say, run on demand, okay, or run on daily basis, daily, hourly. Okay, you just need to choose the time, monthly, yearly, and the glue crawler will run based upon the configuration or settings that you are mentioning over here. It will be keep on running until unless, like if you are going to say schedule it hourly, so hourly, and it is asking, say, on daily basis up to which time you just want to have the execution. Those particular things it will ask. In the next session, once we will start the glue, so we will see these particular things. So at that particular time it will ask the details, like by when you till the time you just want to have the execution of this. So it will keep on running, and on each and hourly basis you will be getting the data. So if like there are multiple files on to this particular path, you have mentioned, say you have mentioned this particular path on S3, and over here we are having single file only. If there are multiple files, then it is going to create multiple tables with one go only. If we are having 10 files, so it is going to create 10 tables in one go only. So that is possible. You just mention like based upon the folders, subfolders, it is going to create the partition table as well, if you are just mentioning the path and based upon the subfolders which are listed over there, it will create the partition table as well, okay. So once you review and create, then the crawler will be created, and AWS glue and say crawler, over here you will be able to see the crawler, so this is the crawler, flight data booster analytics. This is the crawler that we have created, and what you just need to do, you just need to click and run it, and then the table will be created once again. So this is the way like how you will be able to infer the schema or create the crawler, create the tables with the help of AWS glue crawler. Over here just have a look, we are having two things with respect to this is AWS glue. This is the third service that we will be going to learn over here. And over here the AWS glue is going to do what, it is working as a data catalog. So whatever the table that you are creating, those particular tables are listed over here, so say small flight at glue table, Athena test, then small flight opti, small flight data. These are the tables what we have created. So this is a meta store. Data catalog is nothing but it is going to maintain the metadata of your table. What is the location, what is the classification, depreciated or not, table data, and the quality of table. So these are the things with respect to say the tables what you have created, over here inside the data catalog we are having crawler, so this is the data catalog. Second thing what we are having inside the AWS glue, so that is data integration and ETL. So glue is utilized, AWS glue, that is the next service that we will be going to learn. AWS glue, AWS glue, so this is utilized, it is having two uses. First one is data catalog, and second one is uh, data integration and ETL now. So ETL, that is extract, transform and load, and how we will be able to do with the help of AWS glue, that particular stuff we will see. Data catalog, we are able to get the information with respect to the data catalog. Over here we are having the table information, okay, table related information. So how many tables are there, if streaming data is there, so streaming data registry, then the schema. Okay, if you are going to create a schema, then you can have the schema over here. Connection, so like if you want to connect this particular AWS glue with the other services, so we are having different connectors. I will show you how to connect AWS glue with Snowflake, and then you will be able to access the data from Snowflake over here. Then workflow orchestration, so we will be able to create the workflow, sorry, over here schema, then crawlers are there. Inside crawlers we are having classifiers and catalog settings, so you can have these particular settings, like you can encrypt the metadata, and you can encrypt the connection password as well. So this is something with respect to the crawler. You just you are going to create the crawler and tables and you can say in the schema related stuff that will be inferred based upon the data that is placed onto the S3. Yeah. So that's all for this particular session. If you are having any doubt, you can ask. Anything, Swati, Naresh, Shivam, Raj, Rahul, anything that is there in your mind, you can ask.
No, sir. Right now, no.
Okay, okay, okay. So take care then. Have a good day.
Thanks, sir.